Okay, let's unpack this. Have you ever really stopped to think about how that coffee in your mug or, the phone in your hand actually made it into your life?
Hmm,
It's a journey that almost certainly began on the high seas, right? An intricate dance of logistics, engineering, human effort.
absolutely.
Today, we're diving deep into this often unseen but utterly indispensable world of shipping and port management.
Mhm.
I mean, it's a foundational industry that quite literally moves our world.
Indeed. And what's truly fascinating here, I think, is how this industry, operating largely out of sight, really underpins nearly everything we consume, wear, or use.
Everything.
From the raw materials building our cities to the finished products on our shelves, maritime trade, it's like the circulatory system of our global economy.
That's a great analogy.
And we've got an incredibly detailed look today into its mechanics, the dedicated people who make it work, the incredible diversity of ships involved, and looking forward, the cutting-edge technologies shaping its future. So this deep dive, it should give you a really comprehensive understanding. From the fundamental definitions that set the stage, right up to the advanced innovations changing maritime trade.
Right. So, our mission today is to give you that shortcut, to get you truly well informed about shipping. We're going to highlight some surprising facts, hopefully break down some complex systems,
Mm-hmm.
and make sure you walk away with those aha moments. And, a treasure chest of knowledge you can maybe apply or at least impress your friends with.
Definitely worth knowing about.
Okay, so let's start with the sheer scale of it all, because I think that's where the true aha moment often kicks in. Our sources describe shipping as the backbone of global trade.
Mhm.
But when we say backbone, how much are we really talking about? What are the hard numbers?
Yeah, the numbers are, they're genuinely staggering. To put this into perspective, in just the first quarter of the 21st century, the global fleet, so we're talking container ships, tankers, dry bulk carriers, they were collectively responsible for transporting something like 80% of the world's trade volume.
80%. Wow.
80. Think about that. 8 out of every 10 physical things moved across borders goes by sea.
Okay.
And then if you look at it by value, it's still huge, around 70% of its total value.
70%.
Yeah. So this isn't just, a statistic. It means shipping is the actual circulatory system of our global economy. We saw that clearly, didn't we, with the Ever Given incident back in March 2021.
Oh, yeah, and the Suez Canal blocked everything.
Exactly. Suddenly, everything from car parts to coffee was impacted. It just underscores the efficiency, but also maybe the fragility of these global supply chains.
Absolutely.
So these figures, they really highlight how central maritime transport is. It lets goods move across huge distances pretty cheaply, which helps keep consumer prices down, fuels growth. It's fundamental.
And you mentioned a specific data point for growth.
Right. In 2021, the actual volume of international seaborne trade hit 11 billion tons.
11 billion tons.
Yeah. And that wasn't static either. It represented a significant 3.2% increase from 2020.
Okay, so even with everything going on, it was still growing.
Exactly. Shows a steady upward trend. These numbers, they're key indicators. They show the industry's indispensable role in import-export, supporting livelihoods for billions worldwide. It really is the silent engine room of globalization.
So it's not just moving boxes around, it's powering entire economies, sustaining countless livelihoods globally. It's this silent giant humming away, and we rarely give it a second thought. Quite remarkable how vital yet invisible it can be.
Very much so.
That really highlights the immense economic leverage. But I guess with that kind of power comes responsibility too, right? Maybe around environmental impact, labor, things we hear about sometimes.
That's definitely a growing focus, and we'll touch on that.
Okay, but let's turn to the tools first. The ships themselves. When we picture a ship, maybe we just think big boat. But the sources show this fascinating array of specialized vessels, each one designed for a specific job. Can you unpack that for us? What kinds of ships make up the world merchant fleet?
Yeah, that's a great question. Because the diversity is key to understanding global logistics. The distinctions are really important. The broadest category, naturally, is cargo ships. Their job is simply transporting goods, merchandise across the oceans.
Okay.
But within that category, you find several highly specialized types. Each one is kind of a marvel of engineering, optimized for its specific cargo.
All right.
Let's start with container ships. These are probably the ones most people picture. The giants stacked high with boxes.
Workhorses.
Exactly. They're specifically designed for carrying loads in those standardized containers. That's why they're so good at moving manufactured goods quickly, efficiently between continents. The key is standardization. A single large vessel might hold over 1,000 20-foot equivalent units, TEUs.
Okay, TEU. What exactly is that?
Right, so a TEU, a 20-foot equivalent unit, is the standard measure. It represents one 20-foot long container. This standardization is absolutely critical because it allows for seamless intermodal transport. Those boxes can easily shift between ships, trains, trucks, drastically improving efficiency, speed, cost. The whole supply chain relies on it. They carry everything, electronics, clothes, you name it.
Got it. Makes sense. But not everything fits in a box. Right?
Exactly. And that's where general cargo ships come in. They're kind of the versatile workhorses, the problem solvers.
Okay.
If it doesn't fit a standard container, like huge industrial turbines for a power plant or massive construction equipment, maybe even vehicles not on a specialized ship, these guys handle it. They often have their own cranes, too.
Ah, so they can load and unload anywhere.
Pretty much. Even in ports without sophisticated container gear. Makes them vital for reaching diverse markets, especially maybe in developing regions.
Okay, versatile. What's next?
Moving on, we have tankers. Highly specialized for liquids, all kinds.
Right. Oil
Yeah.
tankers.
Yeah. The best known are crude tankers, moving unprocessed crude oil from, say, the Middle East to refineries, and then product tankers, carrying the refined stuff, gasoline, diesel, jet fuel from refineries out to where it's needed.
Okay.
But it's broader than just oil. You have chemical tankers carrying all sorts of things, acids, industrial chemicals, even some food products sometimes. And then the very specialized gas carriers, like those transporting LPG, liquefied petroleum gas, or LNG, liquefied natural gas.
LNG.
Yeah.
That needs special handling, right?
Extremely special. These tankers have incredibly stringent safety and containment systems. Their cargoes can be volatile, hazardous. The design has to manage different densities, temperatures, flammability. Safe operation is absolutely paramount for global energy and industry.
Makes sense. Okay. What else is out there?
Then you encounter the real giants, dry bulk carriers. These ships move massive quantities of unpackaged, loose, solid materials, usually unprocessed commodities. Think vast amounts of iron ore for making steel, coal for power plants, coking coal for furnaces, grain wheat, corn to feed people, scrap metal for recycling, even things like paper rolls, the raw materials that fuel entire industries.
And it's just poured in.
Basically, yeah, into huge holds, makes loading and unloading super efficient. Their capacity is measured in tons of deadweight, DWT.
DWT, dead weight.
Right, deadweight tonnage. It's the total weight a ship can safely carry. So cargo, fuel, water, crew, provisions, everything except the ship itself. And the really big bulk carriers,
Yeah.
they can carry megatons MT of deadweight.
Megatons, million tons.
Millions of tons, yeah.
Yeah.
Huge capacity, directly impacts global commodity prices.
Incredible scale. Are there others?
A few more key cargo types. There are multi-purpose vessels, as the name suggests, pretty flexible. They can carry a mix, maybe some containers, some break bulk, maybe project cargo. Useful when a specialist ship isn't right or a voyage has mixed needs. And for things that need to stay cold. Reefer ships. Specifically designed for refrigerated cargo. Fruits, vegetables, meat, seafood. They need precise temperature control over long distances. Crucial for the global food supply chain.
Reefers, got it. Cold stuff.
And finally, in the cargo category, roll-off ro-ro vessels. These are distinct. They're designed for anything with wheels.
Like cars.
Exactly. Cars, trucks, buses, heavy construction machinery, farm equipment. What makes them super efficient is they have built-in ramps. The cargo just drives directly on and off across multiple decks.
Ah, so no cranes needed for that.
Not for the wheel stuff, no. It speeds up port operations massively. They also carry things like forest products, stuff on pallets, quite versatile for certain goods.
That's an amazing variety just for cargo. Each one a specialized tool. But okay, beyond moving goods, what about ships for people? Or for really specialized tasks, not about trade?
Absolutely. The fleet goes well beyond just commercial cargo. We also have
Yeah.
passenger ships. Now, the official definition is important here. A ship carrying more than 12 passenger.
More than 12. Why that specific number?
That threshold is huge in maritime law. Exceed that, and the vessel becomes subject to much, much stricter regulations and standards. Bodies like the International Maritime Organization, IMO, and rules from the International Convention for the Safety of Life at Sea, SOLAS, kick in heavily.
Soulless, okay.
Yeah, safety of life at sea, it covers everything: structure, stability, fire safety, lifeboats, navigation gear, crew training, all designed for the highest level of passenger safety. So that 12 passengers rule fundamentally changes how they're designed, built, operated, and inspected.
Makes sense. More people, more risk, more rules. What else?
Then there are fishing vessels, designed to catch fish, obviously, and other aquatic life, from small coastal boats to huge factory vessels that process and freeze catches at sea. Some even just transfer catches between boats. Complex fleets out there.
Right.
High-speed craft, sometimes people call them ferries. They're engineered for speed, often use fancy hull designs, hydrofoils, catamarans, air cushions, plus powerful engines, turbines maybe, to go faster than conventional ships. Good for passengers, sometimes light cargo over shorter hops, island connections, busy
I would
waterways.
say fast ferries.
And finally, a broad category: specialist ships. Vessels designed for unique tasks or specific cargoes that don't fit elsewhere. Think research vessels exploring the ocean, cable-laying ships putting down our internet cables.
Oh, right.
Offshore construction vessels building wind farms or oil rigs, dredgers keeping channels clear, icebreakers smashing through frozen seas. It just shows how adaptable the industry is to really specific, often tough jobs.
Wow, cable layers, icebreakers. Cool.
And one crucial piece of tech for navigation, especially internationally: all ships on international voyages must have an ECDIS. Yeah, electronic chart display and information system. It's an advanced system. Shows digital nautical charts, uses GPS for real-time position, helps plan routes, monitor traffic. It's a critical tool for avoiding hazards, bad weather, making passage safer and more efficient globally.
It's easy to get caught up in the ships, the tech, the massive scale.
Yeah.
But none of it happens without people, right? These aren't just driving boats. These are highly trained professionals running these complex machines. Who are they? Who mans these ships?
That's such an important point and often overlooked. The crew members, they're the absolute heart of ship operations. They're professionally trained individuals, truly global workforce, handling everything: loading, discharging cargo, navigating safely between ports, managing incredibly complex, often huge machinery on board.
Sounds demanding.
It is. A typical commercial vessel, say a big container ship or tanker, usually hosts a crew of between 20 to 30 people.
That's it. For such huge ships.
Seems small, right? But highly specialized. This often includes around 4 engineers on the technical side, keeping propulsion, power, all auxiliary systems running smoothly. And typically 2 to 3 cooks and stewards in the galley, absolutely essential for welfare, morale, keeping everyone fed on long trips.
Can't forget the cooks.
Never.
Yeah.
Most crew are categorized as seafarers. They work tirelessly in various roles: wheelhouse, deck, engine room. They oversee a massive range of machinery: the main engine, electrical generators, steam systems, freshwater makers, sewage treatment, ballast water systems. It's a floating industrial plant, basically. Demands specialized skills, resilience, real teamwork.
20 to 30 people running a floating plant. Okay. So what are the different roles within that structure? How's it organized?
It's generally classified into distinct roles, clear responsibilities for safe and efficient operation, a clear hierarchy. First, you have the nautical officers, or deck officers. They're responsible for navigation, steering the ship, plotting courses, communication with other ships, shore stations, and the careful handling of cargo, loading, unloading, making sure it's stored correctly.
And the boss.
The senior-most nautical officer is the master of the vessel, usually just called the captain. They have ultimate command, ultimate responsibility for the ship, crew, cargo.
Master of the vessel. Got it.
And it's interesting, the word nautical itself has deep roots. Comes from Latin nauticus, from Greek nautikos, meaning sailor, from naudus, also sailor, ultimately from nos, meaning ship.
Huh, now it's for a ship. Cool.
Yeah, shows the history, right. And these officers rely heavily on nautical charts, specialized maps, essentially. They show shorelines, the seabed shape, water depths, dangers like reefs or wrecks, positions of lighthouses, buoys, safe places to anchor. Absolutely essential for safe navigation. Planning routes, finding your position securely.
Okay, so nautical officers navigate and handle cargo. Who else?
On the other side, you have engineering officers. Their world is the machinery. Operation and meticulous maintenance of everything mechanical and electrical. Main engine, generators, steering gear, pumps, refrigeration. They keep the ship moving, powered, safe, habitable. The mechanical heart.
Vital.
Absolutely. Then, below the officers, you have ratings. These are the non-officer grade crew. They work on both deck and engineering sides, doing a huge range of tasks under officer supervision, maintaining the ship's exterior, operating deck machinery, helping moor the ship, routine engine room maintenance, the essential hands-on labor for daily ops.
Okay, ratings.
And of course, as we said, the essential cooks and stewards, keeping the crew fed, looking after living quarters, hugely important for morale, health, especially on those long voyages far from home. Their role is crucial.
So we've got the amazing ships, the dedicated crews, but beyond that, there's this whole complex economic structure, right? How the goods actually move from A to B as a business. What are the main models, the structures in the shipping industry?
Right. This is where we see two primary service models that define how operations are structured. They cater to different cargo types, different market needs. Understanding this split is key to the industry's economics.
Okay, what are they?
First, there's liner shipping service. Think of this like a scheduled bus or airline route, but for cargo. High-capacity ships traveling regular routes on fixed schedules.
They're predictable.
Exactly. Predictable timetable between specific ports. Really useful for businesses, maybe smaller exporters or importers, who need regular, reliable service for general cargo, usually containers. Makes planning easy, efficient inventories, predictable supply chains, crucial for consumer goods. The big shipping lines offer these, publishing schedules months ahead.
Okay, liner service is like a bus route. What's the alternative?
The alternative is tramp shipping. A tramp ship does not have a fixed schedule or published ports of call.
So it just wanders.
Sort of. It operates on irregular routes, essentially going wherever the cargo is, wherever the market price is best. They tramp around looking for business.
Okay, what kind of cargo?
Typically used for large quantities of undifferentiated goods, bulk cargoes like grain, coal, wheat, or sometimes break bulk cargo stuff, not in containers. Maybe large, individually handled items that don't need the speed of container ships.
Right.
The flexibility of tramp shipping makes it very responsive to market demand for these big foundational commodities. It's cost-effective for cargoes where volume and price matter more than a strict schedule. These ships are often chartered just for one voyage or a set period based on current market rates.
Liner versus tramp. Scheduled versus flexible.
Got it.
And within this, who are the actual players? Who makes it all happen from sender to receiver?
Good question. The industry can be broadly broken down into three main sections: ship interests, cargo interests, and then this whole ecosystem of other services. Each piece is critical.
Okay, ship interests first.
Under ship interests, you have a shipping line. That's the company operating the ships. They might own them or lease them. Their job is carrying containers and cargo between ports. They run the transport network. And a carrier. This is the person or company actually transporting the goods or people for someone else. Legally, they're the ones responsible if something goes wrong, loss or damage during transport. Big responsibility. They undertake the actual carriage.
Okay, lines and carriers. What about cargo interests?
This side revolves around the goods themselves and the people involved in moving them. The shipper. That's the person or company who contracts with the shipping line or owner to carry the goods. They're the one initiating the transport. They have stuff to move. A charterer. This is someone or an organization that basically rents a vessel, either for a specific voyage or a period of time, mainly to carry their own cargo. They take temporary control of the ship's capacity or even its operation, depending on the deal. A freight forwarder. Think of them as travel agents for cargo. They act as intermediaries, arranging shipments for shippers. They often bundle smaller shipments together to get better rates. They don't usually own the ships, but they handle all the logistics, documents, customs, coordinating everything. They have a strong interest in the cargo moving smoothly. A freight forwarder. And finally, the consignee, also called the importer or receiver. That's the person or company at the destination responsible for receiving the shipment. The end recipient.
Shipper sends, consignee receives, charterer rents, forwarder arranges. Okay. And the third group, other services.
Yeah, beyond those direct players, there's this huge supporting ecosystem, essential for smooth, safe, legal operation. You've got brokers, matching cargo to ships, buyers to sellers, insurers covering the massive risks involved: cargo damage, vessel loss, surveyors inspecting ships and cargo for condition, compliance, damage assessment, flag state officials overseeing registration, legal compliance, port management running the terminals efficiently, stevedores, the workers actually loading and unloading the cargo, port authorities governing the port area, managing traffic, and the Coast Guard, ensuring safety, security, environmental protection in coastal waters.
Wow, it's a whole world unto itself. So many different roles needed.
It really is a complex, interconnected system.
It's really fascinating how a ship, just out there on the ocean, still has a nationality, a legal identity. The sources mention flag registration. Sounds like more than just putting a flag up.
Oh, absolutely. It's fundamental. International law requires every single merchant ship to be registered in a specific country. That country is known as its flag state.
Flag state. Okay.
And this isn't just paperwork. A ship is legally subject to the laws of its flag state. The main purpose: establish its nationality. This allows that state to regulate its shipping activities, enforce labor laws for the crew, ensure it meets international safety and environmental rules.
And protection.
Critically, yes. It allows the flag state to protect the ship under international law, grant it privileges, protections, just like a citizen abroad. So, for example, a ship flying the Indian flag gets the benefits and protection offered by the Indian government and international agreements under that flag. It ensures there's always a sovereign state responsible for overseeing the vessel, its safety, its crew welfare, no matter where it sails. Crucial for accountability.
Right. A legal home base is essential.
Yeah.
Okay, and what about actually using these ships?
Yeah.
Chartering, you called it. Sounds like different ways to rent a ship.
Exactly. Chartering is core to the business. It's basically an agreement where a ship owner rents out their ship or its carrying capacity to a cargo owner. These rental contracts are the charter agreements, often called charter parties. Our sources highlight three main types, each with different responsibilities, costs, levels of control, tailored to different needs.
Okay, what's the first type?
First is a demise charter, also commonly called a bareboat charter. Think of it like leasing just the bare hull of the ship.
Bare boat. So empty?
Pretty much. The owner leases just the vessel to the charterer. The charterer then takes on almost all operational responsibilities. They provide the crew, the stores, the bunkers, that's fuel, and they pay all the operating costs. The owner just provides the ship itself.
So the charterer runs everything.
Exactly. They might even sublet the vessel to others on different charter terms. This type is common for specialized vessels like tankers and bulk carriers, where the charterer wants full operational control for a long period, perhaps.
Okay, bareboat is maximum control for the charterer. What's next?
Second type is a voyage charter. Here, the vessel and its crew are hired for a specific voyage, just from a designated load port to a discharge port, one trip.
And payment.
The charterer pays the owner either per ton of cargo carried or a lump sum for the whole voyage. Key difference. The owner remains responsible for the ship's operating costs, port fees, though usually not the loading unloading, called stevedoring, fuel, crew wages. The payment the charterer makes, that's called freight.
Freight, okay. So this is for shippers who just need one specific shipment moved.
Precisely. They don't want the hassle of running the ship, just transport for their cargo from A to B.
Got it. And the third main type?
That's a time charter. Here, the charterer hires the ship for a stated period of time, could be months, a year, longer, or sometimes for a specified round-trip voyage.
So hiring by the clock, basically.
Exactly, and the rate reflects that. It's often expressed as so much per ton deadweight per month. Payment is based on the ship's carrying capacity, DWT, over time.
Okay, per ton deadweight per month. And who pays for what here?
It's a bit more shared. The charterer is liable for costs directly tied to how they use the vessel, so fuel, bunker costs, port charges, loading discharging costs. They also get more control during that time, choosing the route, the schedule, cargo handling, more operational flexibility.
And the owner.
The ship owner bears the fixed operational costs of the vessel itself, maintenance, insurance, crew wages. It's a balance of control and cost sharing.
Demise bareboat, voyage, time. Three main ways. Are there variations?
Yes, several interesting ones. A trip time charter, TCT, is like a short-term time charter just for a single voyage, but paid at a fixed daily rate, usually semi-monthly. Offers flexibility.
Okay.
You might see a passenger cruise ship charter hiring a whole cruise ship for a private function, like a corporate event. Or a bareboat yacht charter, common in leisure sailing short-term hire of a yacht, often fueled and provisioned, maybe with an owner's employee aboard for a bit.
Right.
And it's worth knowing the term contract of affreightment. It's a general umbrella term covering all contracts for carrying goods by sea, including all these charter types.
Contract of affreightment. Got it. And the players in chartering.
A diverse group. The charterer could be anyone from small companies to huge trading houses, buyers or sellers of goods, even other ship owners, NVOCCs, MTOs, freight forwarders. The ship owner obviously owns or operates the ships, and connecting them is the chartering broker, the essential middleman, negotiating deals, matching cargo to ships.
Okay, so just like roads connect cities on land, there are specific water routes that act like global highways, connecting continents for trade. Our sources list some really critical ones, often acting as choke points too, What are these vital arteries?
Yeah, and what's fascinating is how these routes, some natural, some man-made, drastically cut sailing times and costs, makes global trade feasible. Any blockage, as we saw with Suez, sends ripples worldwide. Our sources point to 8 key routes as vital maritime arteries.
8 key ones. Okay, number one.
First, the English Channel, famously known as the busiest shipping lane in the world.
Busiest in the world. Wow.
Yeah. Separates England from France, connects the North Sea and the Atlantic. Its location makes it a constant hub for ships between Northern Europe and everywhere else. Massive traffic. Needs sophisticated management.
Okay, English Channel. Number two.
Strait of Malacca. This narrow stretch, about 800 kilometers long, is the shortest route between the Pacific and Indian Oceans. Links major Asian economies, India, Indonesia, Malaysia, Singapore. Vital for oil, cargo. Something like 60,000 ships a year pass through. It carries maybe a quarter of the world's traded goods, a third of its oil. Hugely strategic.
Malacca Strait. Shortest pack Indian route. Got it. 3.
Panama Canal. This one's entirely artificial. An amazing piece of engineering, finished back in 1914, designed to cut transit time between the Pacific and Atlantic.
Right. Avoids going all the way around South America.
Exactly. Saved thousands of miles, weeks of sailing time, crucial for trade between East Asia and the U.S. East Coast, or Europe and South America's West Coast. Expanded in 2016, too, for even bigger ships, the Neo-Panamax class.
Okay, Panama Canal. Artificial link. 4.
Suez Canal, another manually constructed canal opened even earlier, 1869, creates the shortest sea route between the Atlantic and Indian Oceans.
Mediterranean to Red Sea. Right.
Correct. Cuts through Egypt, connects the Med to the Red Sea, bypasses the long trip around Africa. Huge shortcut for Europe-Asia trade, especially oil and gas from the Middle East to Europe.
Suez Canal. Another vital shortcut. 5.
Bosporus Strait, that's the Turkish Strait, linking the Black Sea to the Sea of Marmara, then through the Dardanelles to the Aegean, the Med, and out to the Atlantic. It's the only sea access for Black Sea countries like Ukraine, Russia, Georgia to reach global markets. Very strategic, very busy, very narrow. A real navigational challenge.
Bosporus. Black Sea access.
6.
Oh.
Strait of Hormuz, incredibly strategic. Connects the Persian Gulf to the Arabian Sea, then the Indian Ocean. Its importance. It's the choke point for a massive amount of the world's oil. Around 20% of global petroleum, maybe a quarter of the world's LNG, passes through daily. Huge focus for energy security, geopolitics.
Hormuz. Oil choke point. 7.
The Danish Straits. This is actually a system of 3 channels.
Yeah.
The Øresund, the Great Belt, and the Little Belt. Between Denmark and Sweden, Germany. The Great Belt is the widest, the main passage for large ships between the Baltic Sea and the North Sea. Vital for trade in and out of the Baltic region. Germany, Poland, Scandinavia. Gives Baltic ports global access.
Danish Straits. Plural. Got it. And number 8.
St. Lawrence Seaway. Called the most important shipping lane in North America, it connects the Atlantic Ocean way into the Great Lakes, allows ocean-going ships deep into the continent, serving industrial heartlands in Canada and the U.S. It's a complex system. Canals, locks, channels bring the ocean far inland.
St. Lawrence Seaway. North America's inland route. Okay, 8 major highways. But it's not just the routes, right? It's the whole infrastructure supporting them.
Absolutely. These routes wouldn't work without the vast support network we call marine infrastructure and logistics. It's not just the physical stuff, though that's huge. It covers planning, design, construction, operation of marine structures, and the intricate movement of goods by sea.
So physical structures, like
Yeah.
what?
Well, physical support structures include things like offshore platforms for energy extraction, thousands of miles of vital subsea pipelines for oil and gas, and those crucial submarine cables carrying almost all our global internet traffic, laid and maintained by special ships, plus port facilities, breakwaters, jetties, lighthouses, fundamental for offshore energy, global communication, safe port operations.
Internet cables under the sea.
Yeah.
Right. And the logistics part.
Marine logistics. That's the sophisticated brain behind the brawn, planning, implementing, managing every step of a sea journey. Coordinating complex transport chains, factory, warehouse, port, sea transit destination. It's optimizing routes to avoid storms, save fuel, timing port arrivals precisely to avoid delays, managing cargo stowage, navigating the maze of customs regulations. It's making sure your goods move efficiently, cost-effectively, legally from start to finish. A critical, often invisible layer of expertise.
Okay, the world's changing fast. Shipping's a massive industry. It has to adapt, right? Especially with environmental concerns, the push for sustainability. What's this green shipping idea all about? How's this giant industry transforming?
Green shipping is absolutely crucial now. It's a transformative set of practices, technologies, all aimed at seriously reducing the environmental footprint of maritime transport, which historically has been pretty significant, Carbon emissions, marine ecosystem impact.
Right, so what's the focus?
Several key areas. It's about reducing carbon emissions to fight climate change. Optimizing fuel efficiency, use less energy, cuts costs too. Minimizing air and water pollution, things like sulfur oxides, nitrogen oxides, ballast water discharge that can introduce invasive species. Trying to achieve ecological balance, reduce noise pollution affecting marine life, conserving resources, exploring alternative fuels, and just generally reducing waste across the board, from ship operations to end-of-life ship recycling.
That sounds like a massive shift. How are they actually doing it?
Ship design and operation are undergoing radical changes to meet tough IMO green building regulations and other global standards. It's not just talk, it involves real tech and operational shifts. For example, wider use of LNG, liquefied natural gas, fuel. It burns much cleaner than traditional heavy fuel oil, way less sulfur particulates, nitrogen oxides.
LNG, okay. Well,
Advanced rudder and propeller designs better hydrodynamics, more thrust, less drag, less fuel burned. Installing sulfur scrubber systems, these are like exhaust gas cleaners, removing sulfur oxides even if using conventional fuel to meet emission limits. Technologies like waste heat recovery capture energy that would otherwise be lost. Exhaust gas circulation systems to cut nitrogen oxides, better pumps, cooling systems. And looking further ahead, things like solar fuel propulsion, hydrogen, ammonia, exploring truly zero emission options for the future fleet.
hydrogen ships. Wow. So lots of tech involved in making shipping greener.
Huge investment, huge innovation happening right now, aiming for a more sustainable, responsible, and resilient industry.
Okay, fascinating shift. And beyond the green tech, how about navigation itself? How has that evolved from, ancient mariners squinting at stars to today's high-tech stuff?
Oh, the evolution of navigation aids is monumental. Huge impact on safety, efficiency, the earliest forms, basic human observation, simple tools. We're talking rudimentary nautical charts, just showing coastlines, maybe some depths. Fixed structures like lighthouses, warning of danger or guiding ships in. Simple floating markers, beacons, and buoys marking channels or hazards. Mostly visual references, mainly for coastal waters.
Lighthouses, buoys, the class.
Right today. Completely revolutionized by digital and satellite tech. The Global Positioning System, GPS, has made an incredible difference. Precise, real-time positioning anywhere on Earth, down to a few meters accuracy.
GPS changed everything.
It really did. And it's complemented by other satellite systems, boosting accuracy, providing weather data, ocean conditions. Then you have the Automatic Identification System, AIS. Ships automatically broadcast their identity, position, course, speed to other ships and shore stations. Hugely improves collision avoidance, traffic management, search and rescue.
AIS, okay.
And as we mentioned, ECDIS, the Electronic Chart Display and Information System. It integrates everything: GPS position, AIS targets, radar data onto digital charts. Comprehensive situational awareness, largely replacing paper charts now.
ECDIS integrates it all. Makes sense. And you mentioned buoys and beacons earlier.
Yeah.
What's the difference?
Right, good distinction. A buoy floats. It's anchored to the seabed, used to mark channels, dangers, specific areas. A beacon is fixed. It's a structure permanently attached to the seabed or shore, extending above water. Serves similar purposes, but it's a permanent structure. Both are vital navigation aids.
Okay, with these huge operations happening globally, often in really challenging remote places, safety and security have got to be absolutely paramount.
Yeah.
What measures are in place to protect the ships, the valuable cargo, and especially the crews out there for months?
Critical point. And it demands constant investment, constant innovation. How do you ensure safety in such a dynamic, sometimes dangerous environment? The sources highlight several key areas, showing a continuous evolution in protection. It goes way beyond what you might think.
Like what?
Well, first, salvage and firefighting support. Firefighting tech on board has come a long way from just buckets of sand and water.
I'd hope so.
Yeah. Now ships have sophisticated systems, different types of extinguishers for different fires, foam for liquid fires, dry powder for electrical or flammable liquids, carbon dioxide, CO2 to smother fires by removing oxygen, even soda acid types for certain materials, plus advanced detection, automatic sprinklers, trick prevention protocols. Fire at sea is incredibly dangerous, so prevention and rapid response are key.
And sell.
Salvage is the highly specialized job of recovering a ship and its cargo after an accident, shipwreck, collision running aground. Requires huge expertise, Powerful special vessels, massive resources. It's about mitigating loss, preventing environmental damage, not just saving assets, preventing further disaster.
Right. Okay, what else besides fire and accidents? Security.
Huge focus. Security systems and personal safety devices are getting much more sophisticated. Combating threats like piracy, smuggling, terrorism, unauthorized access, ship security is vital. To detect hidden threats, especially in cargo, things like X-ray, gamma ray, and neutron scanners are used to inspect containers non-intrusively.
Scanning the boxes. Okay.
For personnel access, biometric technology is increasingly used. Facial recognition, fingerprint ID, iris or retina scans, voice recognition, controlling access to sensitive areas. Plus, other tech like RFID tags to track assets and people, smart robotic underwater surveillance systems checking the hull for threats or damage, even sensor-based personal safety devices, crewware that can detect falls or immobility and raise an alarm. It's all part of a layered security strategy.
Underwater robots. Wow. Layered security makes sense. And what about emergencies, distress calls?
That's where search and rescue SR facilities come in, standardized globally. The cornerstone is the Global Maritime Distress and Safety System, GMDSS.
The GMDSS.
Yes, GMDSS. It's an internationally agreed set of procedures, equipment, communication protocols used to quickly send a ship's distress signal, its status, location to shore rescue centers and nearby ships using satellite and radio. Ensures help can be coordinated rapidly across borders.
Essential.
And tech like personnel location detectors provide maximum accuracy for finding a sailor who's gone overboard or locating the ship itself in distress, critical for rescue efforts. And don't forget the traditional tools. Loud sound signals like foghorns, smoke signals, pyrotechnics, flares, still crucial for visual and audible alerting, especially if electronics fail. These systems save lives constantly.
It really sounds like shipping is anything but stagnant. Constantly evolving, facing challenges, embracing innovation. So, looking ahead, what are the big technological trends really shaping its future, taking it into the next generation of global trade?
Oh, the industry is definitely in a phase of rapid, sometimes quite breathtaking transformation, moving fast towards a more digital, automated, and sustainable future. Several key trends are fundamentally reshaping how things operate, promising more efficiency, better safety, and crucially, better environmental performance.
Okay, like what? What's trending?
One major one is the growth of sensor technology. Modern ships are getting packed with intelligent sensors, way beyond basic gauges.
Sensors everywhere.
Pretty much. They eliminate the need for constant manual checks. They monitor everything, main engines, pumps, generators, even the atmosphere and cargo holds in real time. This flood of data then feeds into AI, artificial intelligence systems.
Ah, AI on board.
Yeah, for accurate monitoring, predictive maintenance, fixing things before they break, early detection of problems. It cuts downtime, boosts efficiency, it makes equipment last longer. Big impact.
Okay, sensors and AI. What else?
Hand in hand with that is robotic automation. Robots are being developed for all sorts of tasks, enhancing safety, efficiency, even security. Think autonomous underwater vehicles inspecting hulls, robots doing routine maintenance in dangerous areas.
Robots doing the dirty work.
Exactly. Or even concepts for robots that could navigate inside ships or counter threats. Plus mini robots paired with sensors, just collecting and recording data constantly for analysis, freeing up the human crew for more complex decisions.
Interesting. And the big one everyone talks about, autonomous ships.
Right, autonomous ships.
Yeah.
Vessels designed to operate without direct human involvement on board, maybe even remotely controlled. Using advanced sensors, sophisticated AI, machine vision, self-learning systems, they can navigate complex waters, plot optimal routes, maybe even dock and handle cargo autonomously.
No crew at all.
That's the long-term vision for some applications, the potential benefits. Reducing human error, cutting operational costs, especially crew wages may be operating in hazardous conditions. Full autonomy is still early days, but remotely controlled or partially autonomous ships. They're already being trialed. It's coming.
A major shift. What else is changing?
For managing the whole flow of goods, the Transportation Management System, TMS, is becoming vital. Sophisticated software to manage the supply chain end-to-end. Planning, execution, optimizing the physical movement of goods. It lets companies track shipments accurately, optimize routes, manage logistics, automate payments, big savings, more reliable delivery.
TMS for logistics control.
Okay. The IoT, Internet of Things, is also huge, connecting everything, primarily using GPS plus cloud databases, storing data from all the smart devices, sensors on the ship, even in the cargo. The big win. Unprecedented visibility, tracking devices, tracking individual shipments in real time. This lets the industry offer much better customer service real-time updates, accurate delivery times, faster response to problems.
IoT connecting everything. Makes sense. And back to the green theme, materials.
Definitely. Big focus on advanced environmental friendly material. A greener approach to ship construction. Using lighter, stronger materials like fiber-reinforced plastics or advanced high-strength steels allows megaships to carry more cargo more efficiently, reduces the ship's own weight, cuts fuel use per unit of cargo. These materials often resist corrosion better too, last longer, more sustainable overall.
Lighter, stronger, greener ships. Cool.
Now, and directly linked to that, efficient propulsion techniques. Ships use a lot of fuel, traditionally polluting fuel. So huge push to substitute heavy fuels with low carbon or alternative fuels, LNG, methanol, looking at hydrogen, ammonia, to slash greenhouse gas emissions, carbon, sulfur. Plus, clever modifications, modern wind assist sails, optimized hull shapes using things like bulbous bows or air lubrication to cut drag, more efficient propellers, all aimed at boosting propulsion efficiency, cutting fuel burn, reducing environmental impact.
Wind power coming back.
In modern forms, yes. Wind assist is a serious area of research and development.
Okay. And finally, what about the ports themselves?
Port management is also getting a tech revolution, aimed at reducing ship wait times. That's a major source of inefficiency and pollution ships idling offshore or at anchor. New tech predictive analytics, AI traffic management, automated cranes, digital operating systems, optimized scheduling helps ports process ships much faster. Less waiting means smoother operations, lower costs, and critically, less carbon emission from ships just sitting there burning fuel at the docks. Cleaner air in port cities too. Hashtag tag outro.
Okay, wow. Here's where it gets really interesting, summing it all up. We've journeyed from that sheer volume, 80% of world trade volume, 70% of value by sea, to the specific ships, like container vessels holding 1,000 TEUs or more. We've met the dedicated crews, maybe just 20 to 30 people running these giants. We've navigated complex charters, demise, voyage, time charters, sailed critical routes like the English Channel, the world's busiest. And now we see a future being shaped by AI, robotics, green tech. This deep dive really shows an industry that's both ancient in its purpose and incredibly cutting edge.
Absolutely. And if we connect this to the bigger picture, it just hammers home how deeply integrated shipping is with our daily lives, how its evolution directly impacts global economies, the environment. Critical thinking here is key, isn't it? Understanding the definition of WT or the role of SOLAS and the why helps us appreciate the scale, the complexity, the delicate balance. From early nautical charts to today's GMDSS and the coming autonomous ships, every detail matters.
So what does this all mean for you listening? Well, next time you see a product from across the globe, or even just fill up your car, maybe take a moment. Think about the immense, complex, constantly innovating journey it took to reach you. It's so much more than just cargo, isn't it? It's this incredible symphony of technology, people, logistics, global cooperation, keeping our world moving day in, day out.
And perhaps this raises an important question for you to consider as we finish. As automation continues its march, as environmental regulations rightly tighten, with autonomous ships on the horizon and the shift to green fuels accelerating, what new challenges, but also what new opportunities do you foresee arising, both for the skilled people who dedicate their careers to working at sea and for the vital ports that serve as the crucial gateways for all this global trade? Something to think about.